Okay, so let's go to, and this gentleman did a fairly decent job of his presentation, and he named it Substation Components. And this is by Joseph Whittington. He was a student in the previous semesters. First, he has his title page, the Substation Components. And the first slide is transmission. And we're going to go in the same method that we have already taught before, going into the substation, a high side switch, ACI, low side, transformer, low side switch. So it's going to be in the same fashion that you saw in those other videos. We're just going to use this for a presentation. Transmission lines carry electricity from the generating station to the substation and span long distances. So it's an transmission is like the interlinked network from the generating station that goes from substation to substation to substation to substation. All right, high side switch, and pay attention to these pictures. The high side switch does not have a load break, load make device. Well, I'm glad he gave that description because there's none on the switch. It is a visual open point between transmission lines and the ACI. So when I open this switch, I'm going to have one visual open point. The ACI. The MK5 ACI monitors amps and volts. In the event of a fault, the ACI trips with an instantaneous operation, extinguishing any arc in the SF6 gas chamber. The ACI does not reclose automatically. Very good description he's given right there. Right, it is the full gamut of what an ACI does in its operation, plus the medium that it uses to break arcs. And you had this on your previous quiz about what an ACI does. It does not reclose, and it opens on one instantaneous operation. Okay, next slide. Low side switch. It's hard to see in the picture, but I'm familiar with this picture in this location. And you'll see that the transformer here is on the right-hand side. So I know I've come previously, ACI, transformer, low side switch. The low side switch has a load break capability and is the visual open point between the bus work and the transformer. How do I know it's load break? It's got this device right here on it. That's the load break mechanism for this switch. All right, now skip this one. Don't worry about this one. He's missed one piece. What is it?
The transformer.
The transformer. Do not forget to put the transformer in. He's gone high side switch, ACI, low side switch. He missed the transformer. So make sure you get that transformer in the picture, and there's plenty of them. Skip that slide.
What is that?
What is what?
What was that previous picture?
It was a potential transformer.
Is that something that's in a substation?
Say again?
Is that something that would be in a substation?
That will be on a substation. It will be on primary metering. It will be on poles. It will be in transformers that are out there in the field.
Okay.
Okay. This is more a metering department piece. I'm not worried about this as far as your presentation is concerned.
Okay.
Okay. All right. So he comes off the low side switch and he puts an arrow here. Now he's missing one component again. When I come off the low side switch, what's all this flat aluminum right here? What do we call this?
Bus bar.
Bus. All right. So it's low side switch, then bus. All right. Coming from the bus, I then go into the bus side disconnect. These are the three switches that he has right here. And these switches are located on the bus side of the breaker. So you have bus side disconnect, but he did not include the bus. All right, don't worry about this one either. Breaker, so I'm going from my bus side disconnect into my breaker. The substation breaker protects the substation in the event of faults or overcurrent. Good description. It then goes into the regulator, and this is how this scheme is designed. He's coming out of the breaker into the regulator and regulates and maintains voltage within the mandated 5% automatically. Good description. Then it comes out of the regulator up into the line side disconnect. Now the bus side disconnect and the line side disconnect are the same identical switch. It's just the location that determines how I name it. If I'm on the bus side of the transformer, that's a bus side disconnect. If I'm on the line side, you see the lines going out. If I'm the line side of the transformer, that's the line side disconnect. All right, it's another visual open point switch that do not make or break load. They're on the outbound line side opposite the bus side disconnects. Good description. Guess what? That's his last slide. Now, what comes after the line side disconnect? Where do I go out? What do we call these lines that are going out of the substation?
Feeder lines.
Feeder lines. There you go. Add feeder lines. All right. I'm going to go ahead and bring up another one. So let me go back. And I will use this one, Elijah Hawk. And substation components. Let's go through all of his. This will be a little bit quicker because we've already been through it once. All right, substation components: transmission, high side switch, automatic circuit interrupter, transformer, he's got his included, low side switch, potential transformer, don't worry about that one, bus side disconnect, which it helps if you draw an arrow to it, but it's pretty self-explanatory right here. He's taking a picture of all the bus sides. Current transformer, don't worry about. Breaker, he's got the inbound and outbound of the breaker, good picture. Voltage regulator. Line side disconnect. Now, is this a line side disconnect?
No.
No. The line side disconnect is the identical switch on the other side of the breaker. It's this one over here on this side. So he's got the incorrect picture for a line side disconnect.
Doesn't it go in between the voltage regulator and the distribution breaker?
It depends on the scheme of who the person, of how the company built it.
Oh, okay.
Okay. Some utilities like to have a open line side disconnect to the breaker, but the regulator's still in use at the station. Some companies like to have a open line side disconnect and the regulator taken out of service. So it just depends on the direction of how that is done.
Okay.
Okay. Line side disconnect, which is incorrect. That's the incorrect picture for it. This description is right. It's a visual open point, does not make or break load. In order to perform work inside the substation, at least one more visual point must be open. All right, that's a decent description for the breaker, but the picture is absolutely wrong, and is missing the end slide, which is what?
The feeder line.
Feeder line again. Okay. All right, so those are two good examples, and what the plan is tomorrow morning. We're going to get out there tomorrow morning, and let me get this open again. I'll let you know. That picture, the picture, that picture, that picture, that picture, that picture, and you can use that again. I mean, you can use this twice if you want to use this for low side switch. And then your next slide, point to the bus. All right, the bus was missing on his. Don't worry about potential transformer. Bus side disconnect, that picture, not that picture. We're not worried about that one. That picture and that picture, not that one because it's incorrect. All of those were taken from the substation. All the components that we're going to be looking at the substation tomorrow morning for the presentation are in the substation. So be able to take pictures of all of those. Any questions there? Just make sure by what you've seen today, I'll go back to the beginning on this one, is that you get pictures of all components. So what are you going to need? You're going to need a transmission, high side switch, ACI, transformer, low side switch. I would use this picture again. Bus. Don't worry about potential transformer. Bus side disconnect. Don't worry about current transformer. Breaker. Regulator. Line side disconnect picture is wrong. Line side disconnect, and he did not include the feeder. So add the feeder lines that are headed out. You'll be able to get pictures of all those. Any questions there? Okay. All right, let's go into discussion here about the use and the proper procedure for maintaining a capacitor bank or doing maintenance on a capacitor bank. So I have in my photograph here a picture of a distribution capacitor bank, and there is a procedure to follow, both to energize and de-energize and energize a capacitor bank. You guys are going to have to know what those procedure steps are. So I'll get these typed out on a notepad here. And hold this off to the side. All right. Now, what does anybody have any idea? Let's do some reminders here. Let's do some review. What's the purpose of a capacitor bank?
Doesn't it store energy?
Where do we put it? Why do we have capacitor banks on the line?
Near locations with high motor load.
There you go. We have this capacitor banks near location with high inductive loads. All right. This offsets the inductive load and makes the circuit more resistive. And we want to have a resistive circuit, a resistive feeder. So this offsets, it helps compensate for inductive loads. That's why we put capacitor banks at locations. So obviously, I mean, if we have, let's use the college for an example. Let's say it's summertime and every single air conditioning motor is running and water pumps and all that good stuff for chillers and are running, lots of motor load out there at the college. Do we want to have this thing turned on in use?
Yeah.
Yeah, sure you do. You got a lot of motor load going on. Now let's say it's spring and none of the air conditioning is running, and we really don't have that much motor load out there close to the college or in the college. Do we want this thing to be running?
No.
No, go the opposite direction. Now, do you think that every day a lineman's going to be running back and forth to this capacitor bank and turning it on and off?
No.
No. What do you think controls it?
SCADA.
Yes, sir. There you go. Thank you very much. Is SCADA controlled? And this is a lot of technology is going on inside the substation. The substation is getting a lot of readings off the circuit, and it's able to tell when they've got a lot of inductive load on that circuit. And when it recognizes it has a lot of inductive load, SCADA will send a radio signal to this particular bank. It has its own address, and it will either tell it to open or to close, depending on how much inductive load is on the circuit. So it's SCADA controlled. To be able to perform maintenance on this bank, here are the steps. 1, you must obtain, and this is a new one, a CWP, capacitor bank work permit. All right. Any idea why we must get a capacitor bank work permit?
Oh, sure.
So they don't turn it on?
Yeah, it's if you don't, the capacitor bank itself, it just thinks, you know, I'm just in everyday operation and I'm in the capability of turning on or off automatically. Well, we don't want that to happen while we're working on it. So the dispatchers dispatchers will just turn off this capacitor bank when you obtain a capacitor bank work permit. The typical way to do that, just give them the pole number. I'm at capacitor bank on pole 45678, and I need a capacitor bank work permit. All right. This dispatch obtained turns off SCADA to this bank. All right, now let's take a look at the bank here closely. I've got 3 switches at the top. That comes from my feeder line. That switch, and we'll use this one right here, it's one that's closest to us. The low side riser comes down and goes into this device and then to the capacitor cell. Does anybody have an idea what this device is? No answers right there. All right, let me go the safety route. Do we want to open up these switches with the capacitor bank closed and energized?
No.
No, you don't. All right.
Is it some sort of load make?
It is a load make, load break device. Good observation right there. We also don't want to open these switches under any type of capacitance load. All right. So the first step is you can do this by SCADA or manually at the pole through controls is open. These are vacuum bottles. Right. Open vacuum bottles switch. That gives you the capability on all 3. You have to open all 3, one for each phase. That gives you the capability of breaking load inside a vacuum and not with the fuse cutout. Let's put over here 3, just to make sure you guys know 3. All right, 3. Open fused cutouts. Now that I've broken load in here, and we'll go by the low side riser, we're coming down the low side riser into the vacuum switch, but we've opened the vacuum switch up. It's not going to the capacitor anymore. Thus, I can open up the fuse cutout without any load on it. Somebody out there is rustling under their blankets. There you go. Open fuse cutouts, all 3, 1, 2, 3. Now here's a safety feature that you have to maintain on capacitor banks. I think somebody spoke up earlier and said they store electricity. They do, even after they're open. You've got to wait 10 minutes. Wait 10 minutes, then ground the bank. Grounding the bank is a simple procedure here. You can just take your rubber gloves or a stick, pull these caps off, and take a piece of copper and go from here to each side. You'll notice this is the energized side. On the back side, all of these 3 are the grounded side. So you just take a piece of copper, come over here. Now, if you don't wait the 10 minutes and you do that immediately, you're going to get a pretty good snap, a pretty good release of energy at one time. You don't want that to happen. You want to wait the 10 minutes, then ground the bank. All right, 6. Perform any maintenance. All right, that might be as simple as replacing a vacuum bottle or replacing one of these capacitor bank cells or redoing connection or replacing an arrestor, doing anything that you need to do at this location to get the problem fixed. So we performed our maintenance and now we're on, we're going to be on restore. So if you take a look at those previous steps, hold on, let me get this real quick. So since we've obtained those previous steps there, how do you think we're going to do with the go back? What is the first step that we need to take? Good thing that helps out there in your concept, and you use this in your head, is just go backwards. So what do I need to do first?
Undo the ground.
Unground the bank. Okay. Learn how to spell ground here. Got keyboard dyslexia. Unground the bank. Now this wait 10-minute procedure, you don't need to worry about because that's a one-time deal to be able to work on it. What's next?
Would you close the fuse cutouts or would you?
Exactly,
vacuum.
exactly. You're correct. Close. Because if we close the vacuum bottles first, we're going to be picking up load. If we open the bottles, you see what I'm saying?
Yeah.
You want to try to use this vacuum bottle for its full capability, both for braking and making load. Two, if there's a fault or problem, and we'll get to this in just a moment, you can move away from the situation. So we ungrounded the bank, and we closed fuse cutouts. Next.
Close vacuum bottle switches.
All right. And I'm going to go in a different fashion here. On the open, we're really not too worried about this. I'm going to go in a different method right here. 9, period. Move away. And I will let you know, because we're using SCADA, move away, far away. Because we were using
SCADA will close them for you, right?
Right. I mean, you can get the bucket out of the way. You can get down the ground. You can actually, walk 200-300 feet away from this pole after you've done your work. Move away, far away, and then you're going to have what's next? SCADA.
Radio dispatch.
SCADA close. There you go. SCADA close vacuum bottles. When this event occurs and they send the signal to close, now you're going to be re-energizing the capacitor bank completely, all the cells that are inside the bank. I'll have to admit, as far as potential damage and problems that you can have on a circuit, is closing in on a capacitor that is not good, or that has a problem with it. So move away, far away. SCADA closed vacuum bottles, okay? SCADA will actually come back, and there is a window on each one of the bottom of these that shows an open and closed, the green and red symbol. But the dispatchers will be able to see immediately if they have a change in the circuit voltage. All right, they'll be able to see that at dispatch. All right, what's the next piece?
Cancel CWP.
Yeah, cancel your capacitor bank EL. Capacitor work permit. Capacitor bank work permit. Right. After you've done that, then the capacitor bank is in normal operation. So there you have it. You must obtain a capacitor bank work permit. It's dispatch obtained and it turns off SCADA to this bank. Open the vacuum bottles, and that is also SCADA. That's SCADA controlled. Open fuse cutouts, that's you, because you're on scene and there's no automation to it. Wait 10 minutes, vitally important. Then ground the bank. Perform your maintenance. The restore steps: unground the bank, close your fuse cutouts. Remember, you're already in an open state. Move away, far, far away. Have SCADA close the vacuum bottles. Cancel your capacitor bank work permit. Any questions there? Okay. typically when capacitor bank work permits are worked on, it's a two-man crew type situation. So even if you're the guy on the ground and it's typically, line tech A, and then the second person in the truck is a B or a C, so this could be you. Know this procedure, and if you get through the procedure and you're not 100% sure where you're at on it as far as capacitor banks are concerned, don't be afraid to talk with your dispatcher. They will assist you. All right, they will know. They've done this so many times that as soon as you obtain the capacitor bank work permit, what steps are needed to be able to do it safely. Okay, dispatchers are your friend. All right, so Professor V came back just in time. We're gonna take a little break here.
Oh, okay.
All right, and we'll be back. Let's see what time we've got here, 9:47. Let's go ahead and make it 10 o'clock. 10 o'clock will be our return. Of how you do it on an electrical system. And what was most important here, the proper steps to take, the proper steps that are required that are in order. And one thing that's kind of, I won't say it's hard to teach, but it's something to get familiar with, is the proper use of a radio. For one, you want to be efficient in your communications. There's a ton of confirmation that needs to go on. And you want to make it also in that same procedure as far as your communications back and forth to dispatch and back and forth to each other as quick as possible. So you want to sound professional, you want to be professional, and you want to make it as quick and efficient as possible also. So the way we have the part of the field configured right now, and you guys did this a good while ago, is we have two different loops of primary right here, and I'll do a red line one and blue line the other. So we've got this loop in this area, and we got this loop in this area. And really, when we had classes of 16, we only made one loop and put 16 people through it. Well, now they've got two classes. We have the capability of now doing two classes at one time. And hold on, let me change my color here. Black. Okay. There's actually two sets of lines coming off of this one here in the center. That makes the other loop. So when you get started and you go out to the field here, we'll have it pre-set up, and then you're going to have to put it back to normal when you finish. We'll have a location with an open switch. And this is, I'm just putting the O's here just as a general. They might be at any one of the locations. Your procedure, and I'll write the procedure out on a notepad here, is to move the open switch from one point to another, and you get to designate what point you want to put them to. I'm going to number these poles here in just a moment. You get to tell me where you want to move the open point to. And the second step is getting a line clearance. So what does a line clearance mean? What do I have to be able to get a clearance on a sectional line? One open point or two open points? Two open points, okay? And you can designate which line section you want to do. You just have to plan it out ahead of time. Now, once again, you're going to be using a partner with this. So it would be a good idea today, and I will leave the Zoom room open all day. But if you want to talk with your cohort there, that you can talk about or chat, whatever you want to do as far as that is concerned. So I'm going to go ahead and number these poles. Now, we're not concerned with any of these in here. There's no switches on them. There's nothing in between. We only have to worry about the poles that we have switches on. So it's going to be 1, 2, 3A and 3B. I've got two sets of switches on this pole. 4A, 4B on this pole, 5 and 6. So that's the way it's going to be. And you can reference this video again if you need to, or look at it as many times as you want to. That's what the switch numbers are going to be for these locations. This is 501, And this is where we park our cars at here in the yard over here. Now, do understand that I know there's another set of poles over here that we left for the climbers. And there's more sets of poles over here. This is just the two square sections that we made out there at the field to be able to do this. Okay, let me get a notepad up. So screen one, share. Okay, you should be seeing a blank notepad, correct?
Yep.
All right. So the two breakers that we're going to be working with are SRA and SRB. Now, if you want to explain them, that is Singleton Ridge A and Singleton Ridge B. That's the substation that's right beside us. All right. In order to close a switch on a feeder, a procedure must be followed to be able to tie two breakers together. So, one, place SRA and SRB in non-automatic. Two, match regulators SRA and SRB to 120 and turn off. You have to have same matching voltages at both breakers in the substation. If you have a mismatch in voltage, you won't be able to close the switch. All right, you also have to turn off the regulator because what's its normal operation?
Raise and lower.
Regulator.
Yeah, its normal operation is to raise and lower. So you don't want it to move anymore. You have to turn the regulator off. Okay. You are now ready to, first step you have to take to move an open point is 3, close, pole, and this is the one by whatever one you want to designate, question mark. I'm just going to put a question mark here. You designate the pole number. I forgot one step here. Let me go back. Let's go 3. Block ground relays SRA and SRB. All right. Anybody got any idea why we're block ground relays?
So you can't get grounded. Oh goodness, I know what I need.
We're actually, when I say block ground relay, we're taking the ground relay and we're turning it off. We don't want it to recognize things. Now in 3-phase, even on a ground operated air brake, do all 3 switches close at the same time exactly?
What was the question?
On a 3-phase ground operated air brake switch, a GOAB, do all 3 switches close exactly? And I mean to the cycle at the same time.
Yeah,
There's no way.
there's no way.
Yeah. 1/160th of a second, all 3 blades enter at the same time?
Oh, well, close enough.
No, they don't. And there's no way to get precision like that, especially on a handle operated switch that's on the ground. On a disconnect, obviously, we can only close how many at one time? One at a time. So there's even more distance and time right there. If you don't block the ground relay and all 3 switches do not close at the same time, you're going to have load imbalance between the 2 breakers. So that's why we block the ground relay. We don't want that load imbalance to follow the neutral, and we don't want the ground relay to lock out the breaker in the substation or operate it even at that. So you block the ground relay. Close at pole, question mark, you designate. 5. Now that I've got one closed, what do I need to do the other one? We're moving an open point.
Close the other one.
There's no other one to close. You're in a one switch open loop. You're moving an open point.
Oh,
You've closed one. What do we want to do?
Open the other.
Open the other one. Yeah. Open the one you designate. Open, pole, whatever one you want to designate there. Where's my question mark? Question mark. You designate. Right. Once that is complete, you need to go backwards in what you just did. 6. Unblock. Ground relay. SRA and SRB. What else?
Turn on the regulator.
That's all you have to do there. They will go back to their normal operation. Good call there, Paul. All right. Turn regulators on. They're back to normal. Okay. 8. What's number 1 in this list?
Place SRA and SRB in non-automatic.
They are in non-automatic now. What do I need to do now that I'm done?
Switch them back to automatic.
Yeah, exactly. Okay. It is a good process right here that when you get your partner, one of them get assigned SRA and one of them get assigned SRB. So Professor V, you want to do this with me?
and
And you guys will be able to listen to this recording too. Okay, I'm gonna, let's see if I can, hold on one second. Let's see if I can bring both up at the same time. Let me stop this share. Let me move this over here. Get this down to here. And back up. And we'll be able to switch back and forth here from the drawing to the notepad. Do a new share. Share screen. The whole screen. Share. All right, you should see both the paint drawing and the
yep.
that. Okay. So Professor V and I are working together. He's going to be 201. I'm going to assign radio numbers to everybody, and I'm going to be 202. We're going to use this loop section, this one closest to 501. I already have an open point on 6, so I'm just going to use it. And I'm going to move that open point to 5. All right, Professor.
One more time, it's a small screen.
So say again.
Say that one more time. What we're going to do now?
We're going to take, and the 6 is already open.
Uh-huh.
I'm going to move it to 5.
Okay.
Okay. All right. So I'm dispatch the whole time. So you're going to call into dispatch. Dispatch at this time, or you go ahead. You go to me.
Are you ready for me to go?
Yep.
Okay. And you are at, let me get this straight now. You're at your dispatch, right?
Right. I'll be dispatching 6.
You'll be dispatch and number 6.
Correct.
Okay.
You take SRA and I'll take SRB.
All right. SRA. Let me write this down. Okay. Dispatch, at this time, I'm requesting to go to non-automatic on SRA at this time to do some remote switching or some switching in the field.
Okay.
I'm at pole number 5.
Roger, 201, I understand that you're ready to place SRA in non-automatic and you're at pole number 5.
That is correct.
Okay. At this time, SRA is in non-automatic. And I would like for you to match regulators on SRA to SRB and turn off.
Okay. I understand at this time you've placed SRA in the non-automatic position. At this time, regulators are at 120 volts and they are turned off, SRA and SRB.
Okay. All right. At this time, I would like for you to go ahead and block the ground relays on SRA and SRB.
Okay, at this time, the ground relays in SRA and SRB are blocked.
Okay. 202, this is division. This is 202.
Mhm.
At this time, I'm ready for you to close at pole number 6. Division, I understand at this time you're ready for me to close at pole number 6. That is correct. Division, at this time I have closed at pole number 6. 202, I understand you've closed at pole number 6. That is correct. 201, division.
Division is 201.
At this time, I'm ready for you to open at pole number 5.
Okay, I understand at this time you're requesting me to open pole number 5.
That is correct.
Stand by. 201 dispatch.
This is dispatch.
At this time, I have pole number 5 opened.
I understand at this time, 201, that you have pole number 5 open.
That is correct.
Roger, at this time, I'm ready for you to unblock the ground relays from Singleton Ridge A and Singleton Ridge B.
Okay, at this time, I have the ground relays in SRA and SRB unblocked.
Roger that. At this time, I'm ready for you to turn the regulators on SRB back to normal.
At this time, dispatch, I have regulators in SRA, SRB back to normal. They are turned back on.
Roger, I understand you have SRA and SRB back to normal regulators.
Correct.
All right, at this time, I'm ready for you to place SRA and SRB back to automatic.
Okay, at this time, SRA and SRB are back in the automatic positions, back to normal.
Roger that. I understand SRA and SRB are back to normal.
Correct.
At this time, your switching to move the open point is complete.
Yes, sir. At this time, we have moved opening point from number 6 to number 5 and is complete at this time.
Roger that. Okay, so you see the amount of, gentlemen, one, confirmation and repeating your information that needs to go on as far as switching is concerned. And this is a very simple one. I've seen switching procedures that have lasted 8, 9, 10 hours just to go through all the step processes, especially if you need to take a substation out of service to be able to do that. Now, there are some ways to get around and make this kind of expedite this situation. You will hear us dispatchers sometimes say, set up. Now, when I say, and I'm going to do it as a dispatcher, you dispatch to me, set up SRA and SRB. Robbie.
Okay. Okay, and your 202 dispatch.
It's 202.
At this time, I'm requesting you go to non-automatic on SRA, SRB.
Okay. Robbie, if you want to, just go and just say set up.
Set up.
All right.
Okay.
All right. He just says, I want you to set up SRA and SRB.
Yes.
You go through the process as far as you, the person in the field, is at this time, I have placed SRA and SRB in automatic. I have matched regulators SRA and SRB to 120 and turned off. And I have blocked the ground relays in SRA and SRB. So you get to do it all in one conversation. The dispatcher will in turn repeat all of this back. I understand you place SRA and SRB in non-automatic. You have matched the regulators SRA and SRB to 120 and turned off, and you have blocked the ground relays to SRA and SRB. So instead of confirming each step back and forth 3 times, on a setup, you're doing all 3 steps at one time conversation. That is legal. Okay? You can't do anything further until you get to the next step. I'm going to have to inform you to close that poll, whatever you designate, and inform the other person to open that poll. Now, the same thing applies for the go back. All right, the dispatcher is going to tell me, I'm ready for you to place SRA and SRB back to normal. And you're going to repeat back. At this time, I have unblocked the ground relay, SRA and SRB. I have turned the regulators on and back to normal. And I have placed SRA and SRB back to automatic. Of course, your dispatcher is going to repeat that back to you. And then you're going to say that is correct. Any questions so far?
I'd just like to make a statement about the switching instructions from company to company will vary. Procedures will vary. I'll give you Duke's procedures. Whenever we get our switching instructions, just like what you have here, it'll be written out. Because of SCADA, those first few, anything that's done in the substation is usually done by dispatchers, and they will let you know that those steps are complete, and then you will repeat back just like what we did. Repeat back to them that you understand that those steps are complete on his side, that he's already taken care of that.
Excellent, excellent point right there. When you say, and you're going to get a switching order that has a specific number to it. We'll say, what's today? 1, 2.
Just
122-2020. So it's 12/2/2020. You're going to get a designated number, -1. So they're going to have to go through the course of the day. The next switching orders 2, 3, 4, 5 as they go on.
Yeah.
You're going to call in and tell them, well, I'm ready to begin field switching order 122-2020-1. And they're going to repeat that back. I understand you're ready to start switching order 122-2020-1. You're going to say that's correct. The dispatcher is going to reply, at this time, I'm going to set up Singleton Ridge A and Singleton Ridge B. You won't hear anything for a while.
Right.
He's going to do all these things for you. I want you guys to know it
Yeah.
on the surface and be able to speak it out.
Right.
He's going to in turn call you back. My radio number is usually 260. He's going to say 260 division. I'm going to reply. Go ahead. At this time, I have SRA and SRB and not automatic. I've matched the regulators to 120 and turned off, and I've blocked the ground relays on SRA and SRB. I'm going to repeat that back to him. He's going to say that's correct. Then he's going to give me the instruction to, I'm ready for you to close at pole number 5. And I'm going to repeat that back. I understand you're ready to close pole number 5. He's going to say that's correct. So Robbie brings up a great point here. Once he has completed and opened at this pole, the dispatcher is going to say, I'm going to place SRA and SRB back to normal. All that's going to happen behind the scenes.
And you might have to move to multiple points, so it's going to be time consuming. You might have to be at point number 2 and then have to move to point number 4 or 6 or whatever. And it's going to be a little time consuming because you're going to have to travel.
Right. And this is just a simplistic top surface method.
Correct.
All right, so that's moving an open point. Now we're going to use the same. You can do a copy and paste here. Control C, Control V. Now we're going to get a line clearance. We still need to do the same things. Put a line clearance here. Just with a little difference in line clearance. There you go. We're going to place SRA and SRB back in non-automatic. We're going to match the regulators on SRA and SRB. And we're going to block the ground relays. Now that we have already an open pole, remember, we need to change this step. Confirm pole number ? Because you guys are going to designate it, is open. And that conversation goes, if you're designated for that location, 260, are you pole number 5? That's correct. At this time, I need you to confirm pole number 5 is open. I'm going to say, I understand you need me to confirm pole number 5 is open. He's going to say that's correct. I'm going to reply back, at this time, I can confirm pole number 5 is open. Because remember, we keep an open point all the time. All right. What does the next person need to do if they're getting a line clearance? I need how many open points?
2.
Okay. He's going to need to open up pole, whatever you designate, question mark. So we'll just go ahead and say 6 for learning purposes. So he's going to, dispatcher's going to call you. I need you to open up pole number 6. You're going to reply back. I understand that you need to, I need to open up pole number 6. You're going to say that's correct. You're going to call him back. At this time, I have pole number 6 open. He's then going to go through the procedure again. You guys need to talk this out, and you can do it as a full conversation. At this time, I've unblocked the ground relays from Singleton Ridge A and Singleton Ridge B. I've turned the regulators back to normal. I have placed SRA and SRB back to automatic. The dispatcher is then going to tell you, you now have a clearance between pole 5 and pole 6. Test and ground before starting work. Now, we're not going to do the testing and grounding. We're doing this all for it to be able to just know the switching components of it. But that's what you'll get as far as the instructions are concerned. What do you need to repeat back?
I understand I have a clearance between pole 5 and pole 6. I need to test and ground before starting work.
That it, and my dispatcher is going to apply. That's correct. You've now completed that switching order. Sounds kind of time consuming, doesn't it?
Can be.
It can be if you make it so. And here's what makes it time consuming. I'll use Robbie, you call me and I'm 202 and you call me as an example just to do anything.
Dispatch 202.
Go ahead.
We want to go ahead and start our line clearance.
Well, what was the first problem right there? Who did he call? Who did Robbie call? Anybody? Do it again, Robbie.
Dispatch 202.
Go ahead.
We're ready to begin our line clearance.
Who did he call?
You didn't say that you were 202.
Exactly. Remember, there's other traffic that's going to be going on possibly on the radio, and even somebody else might have misinterpreted the 202. Got to reply back with the radio number that you are. All right, you got to reply back with the radio number that you are. So if I say division, this is 260, the guy says go ahead, I'm going to say 260, this is division. I'm going to keep asking until you answer with that number that's designated for you. Okay.
So like if he said 202, this is dispatch, and you said dispatch, this is 260, dispatch is going to just keep repeating 202 until they get them.
Yeah, that's correct. That's correct. All right. We're also going to be confirming, and this is the big thing. I'll give another one here. At this time, I have the switch open. I'm using that line 5 there as a sample. I call you on the radio. You instructed me to open at pole 6. At this time, I'm ready for you to open at pole 6. You reply back, at this time, I have that switch open. Is that correct?
No,
It is not. Why?
No.
you didn't give the pole number.
Exactly. Exactly. You guys are getting the gist of it. It needs to be detailed. All right. And the dispatcher is going to come back again. He's going to ask again. All right. I understand that you're ready for, I mean, at this time you have the switch at pole number 6 open, and your reply needs to be yes. I have the pole, I mean, I have the switch at pole number 6 is now open. That is complete. Once again, it goes for all these steps. You need to use the detail in here. All right. At this time, I have the ground relays back to normal at Singleton Ridge A and B. Is that correct? No, you need to use unblock. You need to go use word for word. And if it's not spoken back correctly, the dispatcher is going to keep requesting it until you get it right. All right, any questions there? It takes
Have
a,
you ever been,
go ahead.
have you ever been doing like a switching something along these lines and somebody comes back in and they're kind of, I guess they're on a pole between where you're at and they're trying to close something or do something and you have to wait?
When, and you see the step procedures here, this is relatively short, 8 steps. And it gives the highlight. When you get a switching order, it may be anywhere from 10, I've seen switching orders up to 900 steps. You can't go out of step order. If that answers your question. If another guy is setting up and he's down there and the dispatcher has just given him an instruction to do something, you cannot proceed to your step until he is done. You cannot go from 1 to 3 or from 4 to 7. It's got to go in step order.
Well, I was kind of asking, like, have you been in a situation where you requested a switching order and somebody's like, hey, I'm actually between y'all, and you didn't know they were there? And you have
No.
to wait to open.
No, no. The circuit's got to be completely clear before you can proceed with switching. That is really scheduled out by your dispatchers.
Right.
Right. Usually the dispatchers have scheduled that out. 2 is, and you bring something up here. What if I am, let's see, Singleton Ridge A and Singleton Ridge B are, pretty two long circuits. What if I'm doing this work here at the college and down towards, the bridge there at Conway, somebody else is on Singleton Ridge A with a hotline work permit? What needs to happen?
That's kind of what I was asking.
Okay. That person is going to have to give up their hotline work permit and stay in the clear long enough for that switching to be completed, and then he can get his hotline work permit back.
Okay. Yes, sir. That's what I was wondering.
Okay, that's appreciate it. Good question.
Mhm.
All right, only one team, the teams that are designated, the crews that are designated, can do switching on those circuits. Nobody else can intervene. Okay, any other questions there? All right, let's take 10. We'll take a little break here. This will be a vital video you guys need to watch today to be able to get out tomorrow and do this quickly and efficiently. And you run into a bump in the road, dispatchers are going to help guide you along, and we'll get this done and taken care of. But I have to admit, from people that have done this out in the field, one is you're learning the processes of what you need to do in the substation, which pretty much takes care of the dispatch takes care of. But the other side is efficient communications. The communications part, as far as working in a utility, is vital. All right, so let's take 10. Let's be back about 10:45.
You got my message?
I have not, but I will in a moment. Okay,
All right.
be safe.
Thank you.
Okay, we are back. It's 10:45. We are back. Well, how do we get all this squared away and how do we communicate with each other? Gentlemen, we're going to use this app that you see on the screen that I have shared. Does everybody see my share screen?
Yes, sir.
All right, does anybody
Yeah.
see my share screen? That's fine. All right, so you can download this app, and if you want to maintain it, keep it, you can. I do have some students that come in and out of the channel every so often. The app is Zello, and it's a walkie-talkie app that uses both wireless or your phone data. Now, if there's no traffic going on in your phone, it doesn't use your data. It only uses data when you talk and somebody talks back to you. If you put it on mute, it's not going to use your data, so it's a good data saver. So you're going to download the app to whatever piece of, if you want to use an iPad or whatever you want to use, obviously a cell phone that you carry out there in the field is the most applicable. Once you have the app and you've confirmed your email address, it's going to ask you to do that to confirm. You're going to join the Santee Cooper channel. And all you have to do is search for the channel. And I'm showing you on PC or on my PC laptop. You can do this on your phone also. All right, that is the method that we're going to be using to be able to communicate back and forth with each other. I will be out at the field, but typically I park a good distance away to give you the real sensation of having to talk back and forth with the dispatcher. So download the app, and if you have a chance this afternoon, go ahead and join the channel. If not, you can join in the morning. If you're having any difficulties, we can square that away out there in the field tomorrow morning. And then once you're in the channel, everybody's able to talk back and forth with each other. Obviously, if you go, and I haven't even signed in here, if you go to Zello and then channels, you're able to look up the channel, you're able to share it with friends. If you do sign in, then you're able to join the channel. So everything can happen on a laptop or a phone. Is there any questions there? You've got to be in the channel to be able to talk with one another in a group. Then you'll be a group of 3 typically. Okay. Do be professional about it. Don't get in the channel and start talking a lot of trash. All right. Any questions as far as the Zello channel is concerned? I'm in it now. So if anybody wants to try it out this afternoon or tomorrow morning when we're coming in, you can just give me a call on that channel. I will let you know I've turned off, if you see right here, it does monitor all the Santee Cooper communications. They cannot hear us when we're talking, but I do have it monitoring all those. Right now I have it turned off for us in class. So if you want to hear actual communications between a utility and the operators that are out there, the men in the field, I will turn that back on after we're done with this portion of the course. Okay, so if there's no questions there, that's the method that we're going to be using as far as communications is concerned.
What's the name of the contact now? Just Santee Cooper?
Santee Cooper is the channel name. That is correct. Right. There are a couple more Santee Cooper channels, and it has to do with the Santee Cooper lakes and everything like that. Make sure you've got this is the only one that has this icon in it.
Mr. Schumacher,
What's up?
I typed it in on the app and it says no results on mine.
Okay, I'll go ahead and share the channel and remind. So then you'll have the direct link. How's that sound?
Yeah, it's much easier.
Okay, will do. I'll go ahead and share it and remind. So you've already
Is this great?
you've already signed in. You already confirmed your email address.
Yep.
Okay, that's fine. I'll go ahead and share the channel and remind as soon as we're done here. All right, so the other pieces that are going to come together, and I will send this out on Remind, and I will post it in D2L also. I went ahead and saved this. So those are your actual field switching steps that you're going to be taking for both the move the open point and the line clearance. So these will be ready-made for you. And you can have them, like I said, in Remind on your phone if you want to be able to use those, or print them out if you want to print them out. You guys, though, are going to be designating which poles you're going to be using, closed pole and open pole. You just let me know that information when you get ready to proceed with the switching order. So that will be provided to you. Any questions there?
Is this a graded?
It is. It is. Right. And you know, you follow the steps, you can't go wrong. It's really going to come down to the point is if you follow this, Paul, step by step and don't get out of step, then everything will be fine. Everybody has done well with this. It's where you're at pole number 1. I mean, you're at step number 3. Then all of a sudden somebody goes and does step number 5. All right, that's a bad thing. All I'm going to do is tell you to back up to 3 and then go to 4. Okay. You got to remain.
Professor Schumacher,
Yes, sir.
Do you have to request to be in it?
Request to be in it?
Yeah, to be in the Santee Cooper on
That is correct.
app. All right, I requested it. I was just making sure.
10-4. Okay, Paul, did you have further questions there?
No, sir, that's all.
Okay. All right. Now, as far as your radio number, I'm going to go through both classes and designate each of one of you a radio number, and I will send out that list also in Remind, and I will also post that in D2L. So know what your radio number is. Any further questions? If there are none, that's it, gentlemen. It's going to take me a little while to get this stuff moved over. Once again, I am in the channel, so if you want to do a test try, that is fine. If you want to wait till tomorrow, that is fine. Just make sure you're able to make communications. And if there's no other questions, I'm going to go ahead and wrap it up. I will let you know there's going to be a lot of remind text coming to you with this information, just to let you know.
Can I ask a quick question?
You sure can. Anybody can.
I'm in it and I'm like looking at the microphone button and it says 4 people's connected. So if I like say something in it, who's gonna hear me?
Everybody that's in the channel.
Okay.
Okay. Takes a little bit of a learning process. That's fine. We've got all afternoon to do that. And if it's not squared away by tomorrow morning, don't get all disturbed about it. We can get it squared away in the morning, even if you have to borrow somebody's phone. No other questions? All right, gentlemen, have a good afternoon. For those guys, remember, quiz 3 is due by midnight tonight. That is available right now. Quiz 3 is due by tonight. Presentations are due next Wednesday by midnight. Presentations next Wednesday by midnight. All right, with that, I'm going to go ahead and say have a nice day. Drive carefully. And I will be on the channel until 2 p.m. this afternoon, coming back at 3, and I'll be on from 3 until 5.
What time at the field tomorrow?
9 a.m.
All right, thank you.
I have one more question, Professor Schumacher.
Yes, sir.
Can I turn that? When will we be able to turn the presentation in?
Today. The Dropbox is open for both classes.
Yes, sir.
Mhm. Okay, time for me to get to work.
That presentation, we still have to take pictures and all that tomorrow.
That's correct. That's
Okay.
correct. Now, you don't have to. If you can find them on the web, they're out there.
Okay. Thank you, sir.
You bet.
Is there anybody left in the room but me and you?
Stand by. Yes, there is.
Okay.
Do I need to take care of that?
Yeah.
All right, stand by.
Okay.
Kind of cool watching your car drive down the road.
Oh yeah.
Yeah, it is. That's
My
fun.
dash cam.
That's a cool idea.
Yeah.
And think of it too, you can record it.
Yeah. I got a ride along.
Uh-huh.
Yeah.
Okay, I don't know if you can hear me. You went to mute. If you can unmute.